write some things down on here. Here's the summary for what you should have written down on there. These are the only forms of electromagnetic radiation that are on this blue sheet. So I have eliminated radio and TV waves. I have eliminated X-rays because they are not on here. I have eliminated indigo light because it is not on here. And these are in the order so that they are showing you that the wavelength of these things decreases as you go from the left-hand side to the right-hand side. Longer wavelength, shorter wavelength. Lower frequency, higher frequency. Lower energy, higher energy. So this is what you are going to need for your test so that things are organized in a manner to best help you. So get that copied down right now, ladies and gentlemen, while I get attendance and some other things. Alicio. Madison, grab your stuff and we'll go next door and we'll finish the test from Friday or Thursday. Calculator? You are going to all the formulas that I had on the board. So, summary of it, so we actually work on some well, for this one, after you read through this, it looks like the volume of the gas created in the reaction. So they need to process the hydrogen gas, you're writing the volume of the gas created. Okay? So each one will tell you what to find. Okay? All right. Everything you need is there. Good luck with it. If you have any questions, come knock at the door. Okay. Anyone need more time with this? Okay, Parker, headphone, please. Thank you. All right, then, ladies and gentlemen, here are starting questions for today. Okay, I've got 5 clues there, 5 elements that you should be able to find and tell me where they go. Now, you have 2 choices, ladies and gentlemen. Reading the question, the element named after the top of a wave is a halogen in the same period as the charge on a nitrogen family member. So, what I would ask you to do is do 3 things. Number 1, identify the element. What element are you placing? So off of your blue sheet, what element are you placing on the periodic table? 2, tell me the group number it will go in. 1, 2, 13, 14, 15, 16, 17, or 18. Number 3, what period number? Okay? Those are the 3 things that I will ask you on your quiz on Friday. What element are you placing? What group number does it go in? And what period does it go in? Now, I don't make you do this, but you could also tell me the current element. So, for example, in group 1, period 1, the current element is hydrogen. Okay? So, read through these 5 questions. Ask yourself, what element am I trying to place off of the blue sheet? Then, what group number is the element going in, and what period number? So the element named after the top of wave is a halogen in the same period as the charge on a nitrogen family member. The element named after the central unit in chemistry is the heaviest alkaline earth metal. Number 3, the element named for the highest energy form of visible light. That was what you just put onto your blue sheet. Is a man-made element with a -2 charge. The element named for a bundle of electromagnetic energy is monatomic in the 4th period. And the element named after the highest frequency form of EMR is the lightest metal with 4 valence electrons. Each one of them leads you to 1 spot on the periodic table, ladies and gentlemen, and each one of them is 1 element. You've got 10 minutes to get that done.
Okay, so what we're doing is we're getting you into places on the periodic table and elements. Okay, so I know you missed Friday because you were taking your test. Okay, so in the notes, which I'm going to show you in a minute, there is an element that is named after the high point of a wave, or the top of a wave. Okay, so you would take the element crestogen and you're going to put it somewhere on the periodic table. Now, this is what the periodic table is going to look like. So it's groups 1 and 2, 13, 14, 15, 16, 17, and 18. Periods 1 through 7. So we're not including this part in here. Okay? So, now, the halogen family is one of these 7 groups. Now, we did take some notes the other day, and I'll let you take a photo of them, where these are for trends that go up and down a family. Okay? So the things that we put on here describe things that go up and down a family. On the back side, when we put some things on here, there are going to be things that go across a period. Trends. Correct. Families and groups go up and down. Periods go across. And they all have numbers. So it's kind of like the game Battleship. If we say period 3, group 15, here's period 3, group 15. Okay? So that's what we're doing with these clues. So halogen family is group 17. Okay? So we're somewhere in group 17. Now, which period are we in? What is the charge of things in the nitrogen family? So that would be what period? The same number as the charge in the nitrogen family member. So the charge is a -3, so which period would that be? So periods are over here. So if it's a -3 charge, it's the same number as the charge of the nitrogen family, which means period 3. So now you come over to the halogens, go down to period 3, and that is the spot where on your test you will be placing the element crestogen. So that's what the test is like. It's going to describe an element, and it's going to describe where on the periodic table to place it. Just similar to these questions. So today it's going to be a little bit more difficult for you, but I'll give you this. I'll put my copy of this out. You can come up and take a picture of this, and then you can use that to put your information in here. Now your test is gonna be open note, open text, open computer. So whatever notes you take, whatever things you write down, you can use, okay? Alright? Now, any other questions?
Yeah, I do.
Okay?
You said, it's in the holiday section 18.
Yep.
And then it's like saying the other charges. These are the things, because the charges that we just said there's 3.
Correct.
Yep. Okay, so this is a period. These are periods.
Yeah, I would, yeah.
I think we're rows.
Periods and rows are the same thing.
Oh,
On the periodic table, ladies and gentlemen, if you look up here, group numbers are the numbers above that describe elements that go up and down. We can call them groups, we can call them families. On the side are periods, 1 through 7. They go across, okay? So, periods go across, groups go up and down, all right? So, here's what we're going to do. We're going to give you about 2 more minutes for those of you who are doing it. If nothing else, try to figure out what element I'm talking about, and then we will work through the others to give you a little bit more practice with them. But this is what I'm going to do every day in this unit, ladies and gentlemen, because this is the exact same thing that your quiz is going to be on Friday. Okay? I'm sorry, Thursday. You're right. Thursday.
wait a minute.
You don't have school on Friday. I do. But that's okay. Yes. Thank you for reminding me. Yes. Thursday.
Central unit in chemistry. Oh, it's right.
Well, you tell me. What is the central unit in chemistry? What is the unit if you have no idea what to do with something you get it into?
Okay.
There you go. By the way, discussion amongst your neighbors is not a bad idea on this. Talking about things is not a bad idea. See what part of the clue you're able to get, what part they're able to get.
Is that the highest energy?
Denia, I did not hear the rest of that question if you were asking it to me.
It's water to the.
In chemistry is the heaviest alpha.
What's the highest?
I will get back to this. Sorry, ladies and gentlemen. There you go. Freeze.
Is it? Wait.
All right, ladies and gentlemen, let's start going through this. Okay. By the way, up here in the front are the pink sheets that we worked on Friday. If you feel like you missed something off of here, when you leave class today, take a picture of these with your phone. Make sure you have everything copied down onto your pink sheet, if you want to, that I have. Again, this is an open note, open book, open computer test. You don't have to copy anything down. But I am warning you right now, you will not have time on this test unless you understand this stuff down, front and back, inside out, to be looking everything up on your computer. So the more things you write down, the more things you put onto these periodic tables, the more organized you are when the test comes around, the easier it is going to be for you. Okay? And again, the nice part about these sheets is they are set up the way that the test sheet is going to be. In other words, if you're in group 14 here, you find that on your periodic table, and now you're looking in the right area, so you're not in the wrong spot. Okay? All right, so question number 1. The element named after the top of a wave. What element is named after the top of a wave? What? What is it? Crestogen. So symbol is Cr. Okay? Now, I need a group number and I need a period. Okay? So, is a halogen. Halogen, is that giving us a group or a period? Group. What group? 17. Remember, we named them all the other day. Halogens are group 17. Okay? Now, same period as the charge on a nitrogen family member. What is the charge on a nitrogen family member? Now, we cannot have a negative period, correct? So what period are they talking about? Period 3. So what element is currently in group 17, period 3? Chlorine. So that is the spot where on the test you would place Crestogen. Okay? Now, on your quiz on Friday, it's going to ask you to do these 3 things. Identify the element, identify the group, and identify the period. That is it. Okay? Those are the 3 things that you are going to have to do. Go.
Crestogen would go with the
What?
Crestogen.
Crestogen. Remember, your test, the answer sheet on it is a blank periodic table. It looks like this. So in the spot where chlorine is on this periodic table, you would put Cr. Move on to your next clue. That is what you will be doing. Questions? Okay, good. The element named for the central unit in chemistry. What is the central unit in chemistry? Mole. Now be careful, because there are multiple elements that begin with an M. So what is the symbol for mole? M. Okay. Now, what group is the alkaline earth metals? Group 2. And then what period would the heaviest alkaline earth metal be in? Period 7. So what current element is in that spot? Radium. Ra. Ra. So that is where you would put the M on your test. Questions? The element named after the highest energy form of visible light. Okay, so first of all, we are talking about possibilities of red, orange, yellow, green, blue, or violet. Which one of those has the highest energy? What? Violet. Violet. Okay. Violetium, Vi. Okay. Is a man-made element with a charge of -2. So which one of those is telling us a group or a period? What period?
7.
Man-made is period 7. There at the very bottom of your periodic table. Starting with the third element from the left. Those are man-made elements along the bottom right-hand corner of your periodic table. Where is a -2 charge? What group? Group 16. So what element is currently in group 16, period 7? Probably going to be a tougher one to pronounce. Livermorium, LV. Very good. Good. The element name for a bundle of electromagnetic energy is monatomic in the fourth period. All right, bundle of electromagnetic energy. Quantum. So that is one that we gave the other day. So if you were taking your test on Friday, quantum is a bundle of electromagnetic energy. It is on your blue sheet. It is partway down. My suggestion is next to the word quantum. To the right of it, you write bundle of electromagnetic energy. Danaya, what can I do for you? Okay, what does monoatomic mean, ladies and gentlemen? One atom. That gets us into what period or what group? Period 18? There is no period 18. Group 18. Monatomic means that it is a noble gas. It is one atom. It is unreactive. And that was on the pink sheet that we gave you on Friday. Under monatomic, under group 18, we wrote stable, inert, unreactive, monatomic. Okay? Now, what period would it be? Period 4 tells us that. So what element is in group 18, period 4? Kr, krypton. The element name for the highest frequency form of EMR is the lightest metal with 4 valence electrons. Okay. Highest frequency form of EMR. On your blue sheet, we just put that at the top. Which one is the highest energy form, or I'm sorry, highest frequency form of EMR? Gamma. GA, I believe, right? Okay. What group are we talking about here? 4 valence electrons, lightest metal. What group? The carbon family, which is group number 14. Okay, now for the tricky part, ladies and gentlemen. Which element is the lightest metal? In group 14. Germanium. Okay, germanium. So what period is germanium in? 4. Now, I am going to warn you, ladies and gentlemen, and I'm going to implore that you do something real quick right now. If I were you, on the right-hand side of your periodic table, I would put the group numbers on the right-hand side as well. Now, the reason that I ask you to do that is because what will happen sometimes to people is they will be going to find the group for germanium. I'm sorry, the period for germanium. We know it's in group 14. And they'll go 1, 2, 3. It's in the third period. What's wrong with that? If you forget that there is an element that is not here, there is a period above this, you will count down and you will be off by 1. So by putting the numbers on the side, it makes it a little bit easier for you to find the period number that we are looking for. Okay? Again, it's your choice. Not telling you you have to. I'm just giving you helpful suggestions. Questions, ladies and gentlemen? Okay. So take your blue sheet out real quick. Amplitude, you should have a definition for. If you don't, in a matter of seconds, I will show you something that you will need. Blue, Mr. Brand, Crest, East High School, Gamma, green. Hertz, you will have a definition for in a matter of minutes. Lambda, Miss Lip, microwave, orange, photon, quantum, red, TRAW, ultraviolet, violet, and yellow. Those should be ones, ladies and gentlemen, that right now you know what kind of clue you're going to get, or you should have information about them. The microwave, infrared, red, orange, yellow, green, blue, violet, ultraviolet, and gamma, that's all on the side here. And a clue may be the element greenium is a second period noble gas. So you may not even have to actually figure out what element we're talking about. But I may ask you ones like, okay, the one that has the highest energy, the one that has the lowest frequency, the one that has the longest wavelength or shortest wavelength. And I may be of all kinds of EMR, or I may be just of visible light. So that is why we wrote those things on the side. Photon, for those who weren't in class on Friday. A photon is a bundle of light energy. A bundle of light energy. And a quantum is a bundle of electromagnetic radiation energy. Okay? Now, the reason I'm giving those to you is because I have to put them into your notes yet. I don't have them in there. I should have them in there on that very first slide, but I don't. I will take care of it eventually, but that doesn't help you right now. Questions? I know that's hard to read, but I'm trying to show you the whole thing. Again, I will put this up on the front. Any questions? Okay. So I'm going into my EISN right now, ladies and gentlemen. I'm starting on slide 5. We went through slide 5 the other day. But slide 5 has 4 definitions that you are going to need for your green or blue sheet. It has crest, the high point or the top of a wave. TRAW, the low point or bottom of a wave. Amplitude, 1/2 the total height of a wave, meaning halfway to top down or middle to the bottom. And wavelength, ladies and gentlemen, whose symbol is lambda. Now, lambda is what is on your sheet, and it means wavelength. So lambda is the symbol for wavelength. So those 4, crest, TRAW, amplitude, and wavelength, are all on your blue sheet. My suggestion is to write down next to them what their definition is so you don't have to look it up in your slideshow when you are trying to find the answer for your quiz or for your test. Questions? Okay, here we go. This slide, I want to go over real quick with you. Okay? First of all, understand, this formula will not be on your test. I'm just showing it to you because it is the relationship between wavelength, frequency, and something called the speed of light. The wavelength times the frequency of any form of electromagnetic radiation equals a constant c. C is the speed of light. The speed of light is 300 million meters in 1 second. Again, not something I'm going to test you on, but something that you should hopefully be familiar with so that if you hear it later on in life, you know what speed of light is. By the way, this is the same C from Einstein's famous equation, E equals mc squared. This C is always the speed of light. Now, all electromagnetic waves travel at this speed. Now, frequency is the number of waves that pass a point in 1 second. So if you were standing there on the highway, counting cars that go by you as you are standing there, the number of cars that go by in a second would be frequency. How often something happens in an amount of time. Now, the important part for this is the unit of frequency. Hertz. It's on your blue sheet. Find the word hertz and next to it put the unit for frequency because that is what it is. Again, lambda means wavelength. And we have another formula, and it relates energy and frequency. But it uses a constant, H. That is called Planck's constant. Now, Planck is on your list, but please wait to put something down for him until we talk about him in terms of the history of the atom. Okay? But it is a number that doesn't change just like speed of light. What this means, ladies and gentlemen, is every different wavelength of light, every different color, has a different frequency and a different energy. Okay? And that is the way it is. Joules is not on there. You do not have to worry about it. Questions? Okay. We are going to start something right now called quantum mechanics, quantum numbers. Okay? This goes for electrons around the nucleus of an atom. All atoms start out electrically what?
Stable.
Nope, not stable.
Unstable.
Neutral, meaning the number of protons equals the number of electrons. How many electrons in the atom carbon? How many atoms, or how many electrons in an atom of carbon? How many?
Wait, you said what?
How many electrons in an atom of carbon? 6. The atomic number on the periodic table is the number of protons. In a neutral atom, it is also the number of electrons. Now, atoms can gain or lose electrons. We know that. But to start out, every atom is electrically neutral. How many atoms in chlorine? I'm sorry, how many electrons in chlorine? My bad. How many electrons in an atom of chlorine? 17. How many electrons in an atom of lead?
82.
82. How many electrons in an atom of silver? 47. If you know the atomic number, which is the whole number by the element, you know the number of electrons. Now, quantum numbers say every different electron has a different address, if you will. Now, what are the 4 things that are in an address if you were to, I know this is crazy, but if you were to actually send someone a letter? What are the things that go into sending a letter to somebody? You need to describe what? The street, the zip code, the house number, city, state. Can we put street and house number together for one? So when you send a letter to someone, you need a number and a street. You need a city, a state, and a zip code. Those 4 things tell you where that person is located. And we get from very general things down to more specific. The most general thing in there is the what? The state. He lives in Wisconsin. Okay, so do a lot of people. So then how do you get it down from there? What's the next most specific thing? Actually, even before city. Your zip code. Multiple cities can sometimes have the same zip code. Sometimes not. So we could make an argument for city or zip code next. I don't care. But they tell you 2 different things, right? And then finally, the most specific thing is the street and the house number. And if you put all those things on a letter, you put a stamp on it, you put it in the mail, it'll get to that person in a few days. Okay? Well, we are going to describe an atom's or an electron's address in 4 ways. There are 4 quantum numbers, ladies and gentlemen. Okay? Every electron in an atom has a unique set of 4 quantum numbers that will describe that electron. Now think about this for a minute. Lead has how many electrons in it? 82. And there are 4 numbers that describe every single electron. So for all 82 electrons around the nucleus of lead, there are 4 numbers to describe each one. So there better be a damn good pattern here if we're going to figure this out, because that's a lot of numbers, right? And there is. There is. Okay? There are 4 types of quantum number. Each number represents something different about an electron. Kind of like each thing in an address represents something different. City, state, zip, street, and number. Each quantum number has only a certain set of values it can be. So there are only certain streets in Green Bay. There are only certain house numbers on a block. You can't just put a random house number down to a random street and hope that it gets there. That address may not exist. Same thing here. So there are only certain numbers you can use. The very first quantum number, ladies and gentlemen, the very first quantum number is called the principal quantum number. We use the letter n to represent it. In other words, there can be certain values of n that represent the principal quantum number. The principal quantum number is what energy level the electrons are in. By the way, in theory, it can be from 1 to infinity. Energy levels, if you add energy to an electron, it can jump to a higher level. Further and further away from the nucleus. Electrons can move. So in theory, the answer could be from 1 to infinity. In reality, ladies and gentlemen, it is from 1 to 7. 7? Just like the number of what on the periodic table? A period represents an energy level, ladies and gentlemen. A period is an energy level. Period 1 is the first energy level. Period 2 is the second energy level. Period 3 is the third. The periods represent the energy levels. And that's why their values can only be from 1 to 7, ladies and gentlemen. 1 to 7. Okay? Questions? Now, at the end, I will summarize this for you So just follow along in your notes. So in reality, ladies and gentlemen, the values of n can be from 1 to 7. That is it. Okay? You can't use the number 8 because there is no 8th energy level. You cannot use the number 9. There is no 9th energy level. Now, we could talk about if they existed, yes, but they don't on our current periodic table. We only need the first 7 energy levels. Okay? The second quantum number, ladies and gentlemen, is the energy sublevel. It is called the type of orbitals. It is also known as the subsidiary number. It is known as the subsidiary number, ladies and gentlemen. Okay? Now, just like the principal quantum number can only have values from 1 to 7, there are only so many sublevels in each energy level. Okay? We use a lowercase l to represent this. And this becomes difficult because you're going to look at it and it's going to look like a 1 when I write it. But it is actually a lowercase l. And the values, ladies and gentlemen, describe the different sublevel shapes. Sublevels have different shapes to them. Okay? Now, there are different number of sublevels depending on what energy level you are in. The higher the energy level, the more sublevels it has. Okay? So the first energy level only has 1 sublevel. Okay? That's it. To find the number of sublevels, we find the integer values. What are integers? They are positive whole numbers. 0, 1, 2, 3, 4, 5, 6, 7. Okay? From 0 to n minus 1. So the possible sublevels go from the number 0 to n minus 1. Okay? There are 7 possible sublevels. Yes, there are 7 possible sublevels. We only currently use 4. So even though there are some energy levels that will have 5, 6, 7 sublevels, the most sublevels that we use on our current periodic table is 4. 4 of them. That's it. Okay? 4 sublevels. That doesn't mean there isn't room for more. That means that's all we're currently using right now with the number of elements we have created and we have on our periodic table. Now, the numbers for them are 0, 1, 2, and 3. Now think about this. The first energy level. What is the n value for the first energy level? What number do we use to represent it?
0.
No. 1. 1. But now for our L value. I'll make it this way to try to make it look more like a lowercase l for you. We go from 0 to n minus 1. What is 1 minus 1? 0. That's it. There's 1 sublevel. That's it. No more in the first energy level. In the second energy level, you have n value of 2. So, 0 to n minus 1. What is 2 minus 1? 1. So we have 0 and 1. 2 sublevels in the second energy level. Third energy level, 3. What is 3 minus 1? So we have 0, 1, and 2, meaning we have 3 sublevels in the third energy level. How many do we have in the fourth? Landon?
4.
How many do we have in the 6th? How many do we have in the 10th? 10. Whatever energy level you have, that is how many sublevels you would also have. Now, the fact is, ladies and gentlemen, that in the 4th energy level, the number is 4. So the values are 0, 1, 2, and 3. And our current periodic table does not need more than those sublevels. We do not have electrons that fill in anything bigger than the 4th sublevel. Questions? So even though the 5th, there are 5. Even though the 6th, there are 6. Even though the 7th, there are 7 sublevels. We only use the first 4. Questions? Okay. Each of those sublevels can also be represented by a letter. So the number 0 is represented by a letter. The number 1 is represented by a letter. The number 2 is represented by a letter, and the number 3 is represented by a letter. And here they are. 0 is for S. 1 is for P. 2 is for D. 3 is for F. Those letters represent those sublevels. And it is a shortcut way of writing those sublevels. We call them the S's, the P's, the D's, and the F's. Questions? Okay. I had done it for you here. Here it is off of the slide, ladies and gentlemen. N is 1, sublevel 0. N is 2, 0, and 1. By the way, very important. That doesn't mean that there are no sublevels. 0 is the sublevel. That number represents a sublevel. So here there are 2 sublevels. Here there are 3. Here there are 4. Here there would be 5, but we don't use the 5th. Here there would be 6. We don't use the 4th or the 5th or 6th. And here there would be 7th. We don't use the 5th, 6th, or 7th. So each of these numbers represents a different sublevel, including the 0. So 0 represents a sublevel. Questions? Wonderful. The third quantum number, ladies and gentlemen, represents the orientation of a sublevel. What is orientation? What do we mean when we say orientation? What is the orientation of this marker right now?
Horizontal.
Horizontal. Okay, so let's try this. X, Y,
Z.
Z. 3 dimensions. We are talking about the real world. We're not talking about something on a sheet of paper. We are talking about things being able to have 3 dimensions. Okay? So the sublevels, because of their shapes, can have different orientations in space. Okay? This is also what is called the azimuthal number. This is what is called the azimuthal number. It is the orientation of an orbit, and the letter M represents it. This is a mathematical model. Okay? Meaning, ladies and gentlemen, we could pick any energy level we want. The 11th energy level. When you pick the 11th energy level, even though it does not exist, because we only need 7 on our current periodic table, we could still tell you how many sublevels there are. Then we could tell you how many orientations there would be, because this mathematical model allows for us to grow if we need to. Now, we currently don't need to on our periodic table. We're not finding any more elements. But that is one of the strong points about this model, is that it has room that if you were to add more elements somehow, we could explain the electrons around them still. The different orientations of the sublevel in space around the nucleus. That is what we are talking about. How is that orientation arranged? Is it on an x-axis? Is it on a y-axis? Is it on a z? Is it somewhere in between? Okay? So, the values run that is negative L to L. Now remember, we had an N for the principal quantum number. Then we had an L for the sublevels. Now we have M. And the values of M depend on what your values of L were. Just like your values of L depended on what the value of N was. That's what I mean by a mathematical model. Each one of these things depends on the previous. Okay? So here it is, ladies and gentlemen. First energy level, there is one sublevel. That sublevel only has one orientation. There is only one way to orientate it in space. And we will show you tomorrow why. The second energy level has a 0 and a 1, which means you have one orientation here, and then the values, if your value of L is 1, you could go from -1 to 0 to 1. You get 3 numbers, which means there are 3 orientations. Guess what? X, Y, and Z. Those are your 3 orientations. Okay? I might as well do this now. Ignore the white stand. What shape is this? Sphere. Still a sphere, still a sphere. I don't care how you turn this. Is there any way that this orientates any differently in space as a sphere, or does it look the same no matter how I hold it? That is why there is only one orientation. How did I get that far ahead? Sorry, ladies and gentlemen. It skipped forward on me. That is why there is only one orientation of this S suborbital. S because that's what the 0 represents in terms of a letter. Okay? Now, have you ever seen Russian stacking dolls? The doll where when you take it and open it, there's a littler doll inside it, and then a littler doll inside it, and then a littler, so on and so forth. Well, this is what the S looks like in the first energy level. Small. In the second energy level, you have another S. But it's bigger. Why is it bigger? Because this is inside of this one. Okay? So we're going outside for the next energy level. We're getting bigger. But there is this shape again, this round shape. Only one orientation. Sorry, this spherical shape. Only one orientation of it, because I don't care how you turn it, it looks exactly the same, right? Okay. But you also get what are called P's. You get 3 P's. This is one, this is another, and that is the third. So they are orientated along the x-axis, the y-axis, and the z-axis. So imagine these together. Okay? So they're coming at you, they're going to the sides, and they are also going up and down, right? Why the white spot in the center? Any idea why that white empty space in the center? That's where the S is. Electrons don't want to be occupying the same space. They are negatively charged. They are repelling each other. So this is the way that electrons can have their own space and not run into each other. Okay? Now, these are the easy ones, the S's and the P's. Now you get into the D's. In the third energy level, you have a number of 0, 1, and 2 for L. Those are your 3 values. So you can have, again, an S suborbital, 3 P suborbitals, and you can have 5 d suborbitals. The d's get confusing because, again, these are offset so that they're not along the x, the y, and the z, because there is already something there along the x, the y, and the z. And you'll notice most of them have their centers open. Even this one, the center is open. The electrons are either running around here or up here. Okay? So again, we have different orientation. I'm not asking you to memorize the shape of these. But if you can remember that the S is a sphere, you'll remember that there's only one shape of it. These, they will sometimes call the dumbbell shape. Like a dumbbell lifting weights. That's what they will use to describe these. Okay? I've never heard anybody give me a great explanation for the D's, and the F's are even worse. Because the F's are the 4 sub-level. So when you get values of 0, 1, 2, and 3 in the 4th energy level, you can have S's, you can have P's, you can have D's, and you can have F's. Questions? Okay. The 4th quantum number is what is called the magnetic spin. Spin is just what it sounds like. Spinning around. Spinning around. The clock spins, correct? What are the directions a clock can spin? What is it? And? That's the only 2 directions you can spin. There is not a 3rd direction that you can spin. Now, what gets confusing, ladies and gentlemen, is if I take that clock off the wall and I hold it flat, is that spinning a different direction? Then you're like, well, it's going like this, Mr. Brand. That's different than on... No, it isn't. It's the same as being on the wall. It's just changing where that it's laying down. There are only 2 ways things can spin. Clockwise and counterclockwise. So there are only 2 values for magnetic spin. You can either use plus 1/2 and minus 1/2, or you can use an up arrow and a down arrow. I don't care which one you choose to use. Okay? Technically, because they're quantum numbers, you should use plus 1/2 and minus 1/2. But understand, if you use an arrow up and an arrow down to represent the spinning, I don't care. It does not matter. Okay? What this means, ladies and gentlemen, is that there are only 2 electrons per orientation of a sublevel. Per orientation. Okay? So let's take a look at it. By the way, the electrons pair up in an orientation, but they can only spin in opposite directions. They will never spin in the same direction in an orientation, because if they did, they would have the same 4 quantum numbers, and you cannot do that. You cannot do that. Okay? The total number of electrons depends on the orientations. So here it is, whole big picture, ladies and gentlemen. If the n is 1, the L will be 0. If the L is 0, there will only be 1 orientation. Meaning, since there is 1 orientation, you can only hold 2 electrons. How many? 2. 1 spinning clockwise, 1 spinning counterclockwise. That's it. In the 2nd energy level, you have 2 sublevels. One that is represented by the letter 0, a sphere, only 1 orientation. One that is represented by those dumbbells. Now you've got 3 orientations along the X, the Y, and the Z axis. Which means all total here you have 4 different orientations. 1 S and 3 P's. For a total of 8 electrons. Okay? 3rd energy level. You have the 0, the 1, and the 2. 0 to n minus 1. 0, 1, and 2. So you would have an S, you would have 3 P's, and now because the 2's, you can go -2, -1, 0, 1, and 2. The values from -L to L There are 5 orientations of a d there. 5. Which means now we have a total of 18 electrons. 5, 3, and 1 is 9 orientations in the third level. Meaning every energy level can hold what? What?
2 electrons.
Well, what's happening to the number of electrons in each energy level? What? Really? 2, 8, 18? That's doubling? But it is getting what? It's getting bigger. Meaning the further you go away from the nucleus, ladies and gentlemen, the more electrons the energy level can hold. Finally, ladies and gentlemen, the 4th energy level. We never go any more than the 4th energy level because it has the 4 sublevels. So does the 5th, so does the 6th, so does the 7th. We never go over the 4 sublevel. Okay? So you get S's, P's, D's, and what are called F's. -3, -2, -1, 0, 1, 2, and 3. So 1 and 3 is 4. 4 and 5 is 9. 9 and 7 is 16. 32 electrons. We never need any more than this. We never need any more than this. Now, could there be more? Sure. In the 5th energy level, you could use the 5th sublevel. We just don't. We don't need to for our electrons. Take out your periodic table. In the 1st energy level, how many sublevels are there? How many? 1. How many electrons can be held in that 1 sublevel? 2. 1st energy level, 2 electrons. 1st energy level, 2 electrons. 1st energy level, 2 electrons. Look at your periodic table. 1st energy level, 2 electrons. Tell me what you notice.
The period is also 2.
There's only 2 elements in your 1st period. 2 elements in your 1st period. Why? Can't fit any more electrons in the 1st energy level than that. Now, in the 2nd period, you have an S and 3 P sublevels, correct? How many total orientations? 4. How many total electrons in those 4 orientations? 8. Look at the 2nd period of your periodic table and tell me what you notice. There what? There's only 8 elements in the 2nd energy level. Why? Because in the 2nd energy level, you only have room for 1 S and 3 P's. Look at the 2nd period. How many elements are in the 2nd period of your periodic table? The 1st period, there are only 2. 2nd period, there are 8. 3rd period, how many? 8. Well, wait a minute. How many should you be able to hold in the 3rd period? 18. So we're missing how many? 10. We're missing 10. That's weird. There should be 10 more elements in that 3rd period, shouldn't there? Anybody notice anything about your periodic table?
Go to the fourth period. Count them up.
18.
What?
They're 18.
There's 18.
In the fourth one?
So that means there's how many in the middle here? 10. Just like these 10 for these 5 orientations. These 5 orientations could fit 10 electrons, right? How many could fit in these here? How many electrons? No, just here. You're right about the total number. How many just here? So here we can only fit how many? No. How many can we fit in the S's? 2. How many can we fit in the P's? How many?
3.
How many electrons though? How many electrons per orientation? 2. So in the S's we can only fit how many ever? 2. In the P's we can fit how many? 6. In the D's we can fit how many? 10. So in the F's we could fit 14. How many right here? 2. How many over here?
6.
6. 6, 6, 6, 6, 6. How many here?
10.
10. 2, 6, 10. Where are these 14?
On the bottom?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You're close. Actually, you're right. Where does this one go?
Oh, it goes in number 6.
It goes right there, doesn't it? Guess what? This one is part of these what? What? 10. How many does that leave then? 14. These down here, ladies and gentlemen, are these. Are these. Now you have just enough time, ladies and gentlemen. Just enough time. This is a summary of what we just talked about. I would write it somewhere. Because here's the thing, ladies and gentlemen. I am telling you right now. I am going to give you clues that says this element is in the same period as the number that represents a p suborbital. What number represents a p suborbital? What number represented S, P, D, and F? Guess we're going to have to talk about that tomorrow. Get this copied, ladies and gentlemen. Get this copied somewhere for yourself. Yes. What? The protons and the neutrons are not equal. They are sometimes, but not always. We said all atoms are neutral, meaning their protons and electrons were equal. Their protons and their electrons were equal, not their neutrons. Protons and electrons start out equal. That's not what it's called. That's what it is. Atoms begin neutral, meaning their protons and their electrons are the same. It is not what it is. It is just, there's not a name for it. It's just what atoms are. Atoms are neutral at the beginning. Have a great day, ladies and gentlemen. We will see you tomorrow. Goodbye, goodbye, goodbye.
Sorry, Trent. I didn't know if I needed Hi, Katie. Hi, Mom. I'm tired.
I'll put this up at the start tomorrow too, if you don't get a chance to finish it. I don't want to make you late.
The main office, Amy and Camila Ferrerio, Juliana Cruz Martinez, Derek Burton, Greg Kleinschmidt.
Yeah, because you didn't get all of that when you were taking the. Well, you were just gone. Whatever. You just chose to ditch my class. I know. Thank you. Elsa.